508A. It kind of has a nesting doll effect, so it has to comply to not only NFPA 79 and UL 508A, but also the NEC. So you can kind of see how these things stack up. There's also the UL 1449 standard, which is the UL standard for surge protected devices on the power side. So when all these standards reference a power circuit or the power side of a system, they're dealing more with the UL 1449 standard for the surge arresters, which will play into our discussion later. So with the code requirements and timeline for SPDs, we can go into the details of NEC, but just kind of give a background that we don't need to dive into the very nitty-gritty details today, but if you're interested, we can absolutely talk about those a bit. So in 2014, the NEC had requirements for surge protection on emergency systems and critical power systems. And then in 2017 is really when industrial machinery started being mentioned and a reference to NFPA 79 kind of came about. And with the NEC being revised every 3 years, NEC 2020 recently came out, which several states have adopted, and that started adding dwellings into the listing of locations that SPDs may be required. So with the standard being kind of revised every few years, it's important to understand, where your particular state, in this case, lastly, you're in Kentucky, so how Kentucky kind of falls with the different NECs, because it is passed, even though it's a national electric code, it's passed state by state, or sometimes even smaller than that, maybe city by city, depending on which state you're in. So it's important to understand where you are in, but also where the machine may be installed or where the cabinet may be going in order to comply with the NFPA 79 standard and NEC. So there's also been some changes to NFPA 79 over the last few years. So although NEC and NFPA 79 are nested like we were looking at earlier, they're different standards. So they have different committees and they're revised on different cycles. So where NEC is revised every 3 years, NFPA 79 is revised every 3 to 5 years. And that's usually depending on what type of feedback they receive from the field. So with the National Fire Protection, they're just trying to make sure that the risk mitigation that we were talking about earlier, we're seeing what's happening actually out in the field and how can that be prevented in a cabinet. For the installation requirements of SPDs, it was mentioned in 2015, however, there's no actual requirements. So when the most recent edition of NFPA 79 came about in 2018, was the first actual requirement for it. And that's the actual article number for the requirement usage of SPDs in these types of applications. And within that, there's also this language. So I think it's pretty important to highlight this, and that's why we have this in there. SPDs shall be provided for industrial machinery with safety interlock circuits to protect against the effects of overvoltages due to lightning or switching surges. So the code is looking for applications where there's a safety circuit and then somewhere upstream of it to protect the power side, because it's important to remember the power side of the circuit is being protected. With these this SPD, they're looking to protect against lightning electromagnetic pulses or switching electromagnetic pulses, which are pretty robust things to be protecting against. So there's a few requirements that lists in there as well to help protect against those. That's important to keep in mind as we're going forward. And this also was, like I mentioned before, first mentioned in NEC 2017, but NFPA 79, most recent version 2018, is what actually requires the SPDs to be used in these applications. So now we have a bit of understanding about the new requirements. It's important to understand to comply with the new requirements. One of the popular questions I'm asked with this presentation is, after I've kind of discussed this, is how to find the right type of surge protection. And it's important to understand, while surge protection is protecting your system, it's in some regards similar to circuit breakers, and that's protecting your system. Circuit breakers are protecting your system against overcurrent and short circuits. And those are sized according to what your nominal amperage draw is of that circuit. However, with surge arresters being similar in that they're protecting the circuit, these are instead protecting against the effects of overvoltages or transients in the circuits. So first things first is defining what the nominal voltage or what you expect to see at your application. And then finding a listed SPD for the application. Part of the new codes is that it has to be a listed SPD by a nationally recognized testing laboratory, which in the case of the US, the most common one that we have out here is UL. So if it's UL and it's listed, it checks off that box as well for complying with NFPA 79. And then you have to install listed SPD in the application somewhere upstream of the power, or not the power, but the safety circuit, to make sure that you're protecting the power side of that safety circuit. We also have a great landing page set up. So phoenixcontact.com/2018-NFPA79 is a really great landing page we put together here in the US to make sure that everything looks how it should for the US market. Has lots of different FAQs along with diagrams and explanations surrounding this code and how best to comply with it. It's a really great resource for everyone out there, but we also will make sure to send that along afterwards as well, as that is a very good website to use as a resource when looking to comply with NFPA 79. So with those different circuit protection requirements, there's also the VAL-US series. So this is our most popular line for complying with NFPA 79. And the reason is that it checks off all these great boxes across the line. So with it being UL listed and DIN rail mountable, it checks off some of those boxes. UL listed type 1 is also very important, which means that can go most anywhere in a facility. So type 1 versus type 2 versus type 3 is important to understand, but really type 1 can go anywhere within a facility. It can go at the junction box where the power comes in, or it can go all the way down to individual devices to protect them as well. So it's a very versatile product to work with that. It's also VAL-US. The -US means that was designed by Phoenix Contact for the US market, for kind of North America to be used. So it's designed for the voltage systems that we have here, so it'll work great in those applications, and it's tested by UL to those standards. Also has a 200 kA SCCR, so if that is something that's of importance to an application, I know some people, they don't care as much about the SCCR rating. Some people care a lot about it. 200 kA SCCR should be more than enough for most applications. They're also pluggable and hot swappable. So on the screen here, you can see there's a couple different plugs kind of sitting in a little nest here. Those plugs actually will pop out of the surge arrestor. So if the surge arrestor consumes itself over its lifespan, you can throw in a new plug where the one plug may have gone bad because it's protecting your system from those transients, and it's all good to go. It also has the local and remote monitoring to let you know when it does need to be replaced. So there's two windows here on either plug, also a little green contact down here. Those two windows have a little flag in them, a mechanical flag, so it's red for good, or red for bad, green for good, and also the green plug on the side is a normally open, normally closed contact to let you know however you want, whether you want to close or open when one of the arrestors maybe isn't sitting in the cradle very well, or when it has gone bad, to let you know that your system is not fully protected. And also a great landing page for this product series as well is phoenixcontact.com/val-US. This has a great landing page for the whole array of products that is out there with the VAL-US series. And again, all these are UL listed type 1, so these are a great option to comply with NFPA 79, or to help comply with it. There's also our plug trap series. So with our plug trap series, we have a few different arrestors out there, but this is the most popular one for our limited lifetime warranty program, which I will go over in just a second. But our plug trap has just one arrestor in the series that will help you with NFPA 79 compliance, and that is the 120 AC/DC arrestor. So that's what's pictured on the screen. Same as before, it has the plug that is hot swappable and the window up top to let you know for local indication, along with the contacts on the side to let you know for remote indication whether or not your arrestor is protecting your system. You're also Class 1 Division 2 if that is something that is of concern or is needed for an application. These particular line of arrestors do have Class 1 Div 2. And also coming soon is our box trap series. So if you need something that is in a box that is separate from the panel, whether it's because the panel is hard to get to because you need to suit up with PPE, or if you want outside the panel just for servicing needs, or if you want to protect the power and signal line, and it's fully configurable in the box. You need a 4X rating, any of those reasons. This is a great option. The box trap series and system trap series will be coming out soon with new revisions, so that's a great thing to look out for as well. For the actual application, I know it can be a bit much to kind of figure out how this actually affects the application, how to properly install the arrestor in the application. So we kind of have a mock diagram here. So in the mock diagram, there's a few different safety components here. So there's the safety I/O, there's a safety controller, there's a safety relay, and there's also a safety motor starter, all kind of circled there on the lower part of the screen in purple. So all those different circuits can be or have to be protected with NFPA under the NFPA 79 code with a surge arrestor. So upstream of all of them, you could protect all those individual devices, just upstream them. However, when we're looking at the SEMP and LEMP transients that we were talking about earlier and what the code calls out you're trying to protect against, the most common path for those to come into the cabinet is through the power lines. So with the power lines, that's typically we're looking at the AC side, and that's actually the surge arrestor we have up top, just upstream of the power supply. So that's oftentimes the best location to put these surge arrestors, but it may not be enough for all applications. It's just the most common one that I run into is having the surge arrestor just upstream of the power supply is a great place to put it, and ensuring the surge arrestor is in compliance with the listing and the different types of codes that come around that surge arrestor. There's also the potential that outside the cabinet, these I/O points or these safety relays or safety motor starters are running into different devices out in the field, which normally isn't a huge problem. However, the 24 DC side, I mean, it's not usually susceptible to these transients because the power supply provides the isolation and the surge arrestor helps protect it. But if the cable runs are greater than 25 feet or equivalent to it, the statistical likelihood of a transient entering through those cable paths outside the cabinet exposes the 24 DC side quite substantially. So it's important to consider adding in surge arrestors on those lines as well. They may not be needed for all NFPA 79 compliance, and they may not be needed for all applications, but it's important to consider when looking at cabinet, having the surge arrestors to help protect against those transient paths that may be entering the cabinet. And just to circle back to the initial setup with the surge arrestor and the power supply, this is our most common setup for a limited lifetime warranty. So with our limited lifetime warranty program with Phoenix Contact, we really stand behind the quality of our products and what they can do for you. So we set up a program with our power supplies and surge arrestors. So if you install our surge arrestor upstream of our power supply, most everything in that cabinet, including the power supply and the surge arrestor, is warranted for life. There are a few minor exceptions to that, and I can go into that if that's of interest if you guys talk about today or individually later. But it's a great program we have set up, so most everything, including the safety I/O, the safety circuits, anything like that, they're warranted for life if it's Phoenix Contact. So any Phoenix Contact devices in those circuits are warranted for life. And it's really an awesome program we've seen a lot of success with, and I highly encourage you, if you're already considering looking at our surge protection, also look at some of our power supply offering out there. We have fantastic lines that may fit your application. And it also kind of brings us back around to our circle of protection. So going back to the diagram we were looking at the beginning of the mock machine floor, circle of protection is a concept we have at Phoenix Contact. So if you have devices on the floor, so what's devices, whether you have the panels themselves, you have the machines, or the factory as a whole, when you're trying to protect it, you have to look at all the different transients that could potentially enter it, and they enter those through conductive paths. So whether different cables, power, coaxial, data, signal cables, all those potential paths for transients, but some of them are more susceptible to than others. So you have to look at the whole application and make sure that the major paths that those transients might be coming in on are protected. So we have a whole array of products you can kind of see in the circle on your screen to the right, different types of surge arrestors to help protect those different paths from those transients that may be entering your system. So we have a power arrestor there, a few different signal arresters over in the green area, a coaxial arrestor in the upper blue area, and a data arrestor in the left yellow area. So like I mentioned before, you have to consider all different paths and which are going to be more likely than others, because it'd be very difficult to protect every single path entering your cabinet. However, some of them are going to be a lot more likely than others. You have to make sure not to leave the back door open. And then to round it out here, we have a few different tools and resources. So like I mentioned before, the NFPA 79 landing page. That's a great place to go if you are interested in finding out any general information about NFPA 79, how to comply with it, and some of the FAQs that come up frequently when we do these calls or when we just get calls into our technical service department. We also have a Ready for NFPA 79 brochure and common questions that come along with that, or the NFPA 79 website that can help with the discussion of complying with the new code. There's also additional information on the Value S series, which is our most popular series to comply with NFPA 79 because it is designed for those US voltage systems and checks off all the boxes for those new requirements. We also do have a product video and a product brochure out there on that series of surge arresters. And kind of wrap it all up, there's lots of different standards and codes that affect installations. It's important to understand how all them, how they all affect your individual installation or a grouping of installations. And NEC and NFPA are continually evolving documents, and it's important to understand which ones you need to comply to. I know it can be very complex, and we'll have a map up here towards the end that shows the different locations that the different codes may be applying to different installations. Value S series is a great option to meet it again. Again, there is a landing page we have out there for the Value S series and how that can help comply with the NFPA 79 standard. And as long as we're talking about surge protection, it's important not to leave the back door open. You have to use the circle protection because even though you're protecting the power paths for those safety circuits or for your cabinets, it may not be the only path. And we only see the NEC getting stricter over time. And to comply with the true spirit of NFPA 79, it's important to protect all the different paths for those transients that are likely to enter the cabinet. And we also have the NFPA 79 landing page out there. So I'm going to wrap it up with a map of NEC codes in effect. So I got this from the NEC NFPA 79 website. They update it every couple months, but these are the current states that are in compliance. So NEC 2017 or newer are the actual states that are going to be requiring NFPA 79, and all the other states that maybe aren't up to code with NEC 2017. Several of them are in process, so that means that they've said, yes, we're going to comply with NEC 2017 or newer, but they just don't have a effective date established yet. So it might be January 1st of next year. It may just be sometime in the future, but they are moving in that direction. And with that, do you guys have any questions? I may have missed some in the chat here. I can pop that open. If you have any questions, feel free to throw them in the chat. Send them along. I will say, if you guys are just typing them up, I will say one of the most common questions that I'll get after this presentation is with NFPA 79 being a newer standard and lots of people trying to publish content out there to help address this standard. There was some people that posted that only type 1 arresters are, that is the only way to comply with the NFPA 79 code. And actually, you can use type 1 and type 2. It doesn't explicitly state for a type 1 arrestor to be used. The nice thing about type 2 arrestor is it's a lot slimmer, as you saw with the plug trap line, and it's also generally a bit more cost efficient than type 1 arrestor. And it's got the class 1 division 2, as I mentioned before, with Phoenix contact. So it's a great option to look at as well. So you're not necessarily forced into buying a larger type 1 arrestor if the application doesn't call for it.
Mike, I have a question. We've got a wide variety of different types of customers on this call. There's industrial end users. It's pretty self-explanatory for them in terms of they're in Kentucky, so they just need to look at the map and look at what Kentucky is saying as far as what they've adopted concerning the NFPA 79 requirements. But for example, if we have a OEM, several machine builders are on this call, and I've got machines that I'm building in Kentucky, but they're going to end up in California, or they're going to end up in Montana or Florida. Do they adhere to the standards in Kentucky, or do they adhere to the standards that are in the local municipalities?
Yeah, absolutely. That's another great point. We have some manufacturers, actually I'm based out of Michigan. We have some manufacturers up here that ship all over the US or sometimes ship internationally. And really what that comes down to is who's inspecting the panel. So it's not the UL inspector, like we were looking at before with UL inspecting that 508A cabinet. That's actually that local inspector I was talking about. So it could be a state inspector, it could be whomever, and it's wherever they're inspecting it. So if they're inspecting it not only in Kentucky, but the location they're being shipped, the panel's being shipped, there is a good chance you still have to comply to it, even if you're shipping it to, say, Missouri, and you know that the location doesn't need to comply with it. You may still need to comply based on the inspector that comes in Kentucky, or vice versa. If you're shipping to a state that has a more stringent code, you may need to comply with that one as well. So I've had several large manufacturers that ship all over the US just standardize on certain surge arresters because they know common voltage systems they're likely to see, just to kind of take that headache out, because it can be, you know, quite the thing to comply with this, but put an asterisk next to some panels that either comply or don't comply to different types of codes. Best practice, especially as NEC is getting stricter, is just comply to some of the newest codes, which in this case includes NFPA 79.
So what you're saying is they need to go to the map first that the NFPA 79 publishes and look at where that machine is going to be placed, or the system. And we do have a lot of systems integrators that are building systems for customers around the United States as well, and look to what the local NFPA 79 standards are, not where it's being built in Kentucky. Is that correct?
Yeah, well, it could be either, because it really depends on where the inspector is. If the inspector comes in at that location where it's being installed, they have to make sure that's good for commissioning. They may also look at different panels being at the location they're actually being built. That's where it gets a little tricky, because it depends on the inspector and where they are. So best practice is, especially with some automotive customers that we've had up here that ship all over the US, is just comply with the newest code, which most of them have moved up to the NEC 2017 standard. So they find complying with the NEC 2017 standard, their panels works out really well. So if they have a safety circuit, they know what they have to do to surge arrestor.
Gotcha. Okay, I don't know if there's any other questions that you've got on the chat side of it or not.
I haven't seen any come through, but if I may be missing something, feel free to throw it in the chat again, or let me know.
Okay. All right. Well, while we're waiting on anybody to send something in on the chat, I did want to say that everyone that's attended the call or that is on the call will be receiving a recording of the webinar that you can go back and reference later. You'll also get a copy of the presentation and links to different literature for the products that Micah referenced. But again, this was the intent of this is really to give an idea of, I think the main theme is that you've got to really check with where the machines are going in the municipality that it's going into. And you're still subject to, it sounds like, if you're an OEM, having a local inspector come in to your facility in Kentucky and take a look at the equipment you're building, and they may not still line up with where it's going. So it can cause a lot of confusion on this, and I guess the best thing to do is look at where the machines or the systems are going first. And I guess if you are compliant with the 2020 NEC, which very few states at this point have adopted, that will make sure that you're covered on everything. But right now, I guess the 2017 would probably be the one that would be the standard that most of the states, over 60% of the states, are currently adopting at this point, or have adopted at this point. So if there's not any other questions, then we'll go ahead and wrap this thing up, and we will talk to you guys later.
Thank you very much.
Thanks, Micah.
Thank you.